3 over 4 plus 4 root 5 is against the law. Why? Because there's a square root in the denominator of a fraction. This process is called rationalizing the denominator. You're not allowed to have a denominator in the square root of a fraction. Now, in a previous video, I had just a square root in the denominator. Now I have a binomial. So what do I do if I have a binomial and a denominator and I need to get rid of a square root? Well, you multiply the top and the bottom by its conjugate. Now, a conjugate is literally the same exact thing, but flip the sign in the middle. So I'm going to multiply the numerator and the denominator by 4 minus 4 root 5. Okay, now let me write that out because it's going to be a little unpleasant. 3 times 4 minus 4 root 5 all over parentheses, because this is a parentheses, it's in one group, 4 plus 4 root 5 times the quantity 4 minus 4 root 5. Now, why is the conjugate important? What's going to happen? Magic is going to happen. You'll see. But let's worry about the numerator first. This is just distributive property. 3 times 4 is 12. And 3 times negative 4 is negative 12. Square root of 5 comes along for the ride. Now, what makes the bottom magical is when you multiply binomials, which means two objects in a parentheses where one is a positive sign and one is the minus sign. This is called a difference of squares. The two inside parts will always cancel out. Yes, this is a FOIL problem, but watch what happens. 4 times 4 is 16, no big deal. 4 times negative 4 is negative 16, square root of 5 comes along for the ride. 4 times 4 is 16, square root of 5 comes along for the ride. See what happens in the middle? And then 4 times negative 4 is negative 16. Square root of 5 times square root of 5 is square root of 25. I'll clean that up in a little bit. Now, the reason why this is good is, again, if you're looking at this and saying, I thought we were supposed to get rid of the square roots on the bottom. Give me a minute. Be patient. Nothing happens in the numerator. Nothing at all. Okay? 16 is still 16. But negative 16 root 5 plus 16 root 5 cancel each other out. That's the purpose of difference of squares. And if you're like, but you still have a square root here. 16 times the square root of 25 is the square root of 25 is 5. That's right. So you are left with 12 minus 12 root 5 over 16 minus 80, which is 12 minus 12 root 5 over negative, 64? Now, technically, I can do more with this, but I'm not going to worry about it. Right now, my focus is just cleaning this up, making this look pretty. Okay, so if your teacher is like, you're good, stop the video right now, you're good. If your teacher is going to make you simplify this, then keep watching. Okay, now, we are technically not done yet. Okay, technically not done yet. If we need to simplify this further, you might notice that both of these have, well, first off, you have a 12 and a 64. Those all have 4s in common. I'm trying to think in my head. Yep, 4s in common, and that should do it. So what I can do is if I were to keep going, you can factor a 4 out of the numerator, which would make it look like this. You can factor a 4 out of the denominator, so that would be times negative 16. The 4 over 4 cancel each other out, and you're left with a final answer of 3 minus 3 root 5 over negative 16. So that's the correct answer technically. I think most Algebra 1 teachers would be okay with that, but we did both. So there you have it. You're welcome.